Hi, this is Prasanna from Wave Academia. In this video, we are going to discuss about vehicle dynamics modeling using Matlab with drive cycle source. The agenda of this video is to learn about motion and dynamic equation of vehicles, how to calculate the wheel radius, total tractive effort required to drive the vehicle, torque and power required to drive the vehicle with the help of drive cycle source in Matlab. Before we moving on to this Matlab simulation, we will just see about what is motion and dynamic equation of vehicles, what are all the opposing forces involving in vehicles, then we'll move to the Matlab simulation. So if you look at this dynamic equations, the basic principle behind the dynamic and motion of vehicles is Newton's second law of motion. According to Newton's second law, the acceleration of an object is proportional to the net force exerted on it. In a vehicle, several forces acting on it and the net or resultant force which governs the motion of vehicle according to Newton's second law. That means the propulsion unit of vehicle delivers the force necessary to move the vehicle forward. Here, the propulsion unit is nothing but it is a combination of IC engine with fuel tank in conventional vehicle. In case of electric vehicle, it is a combination of electrical machines with battery. The acceleration of vehicle depends on so many factors. For an example, the power delivered by the propulsion unit, road conditions, the aerodynamics and composite mass of vehicle. The vehicle motion can be completely determined by analyzing the forces acting on it in the direction of motion. So the total force required, we normally call it as the tractive force, is nothing but it is a force in the contact area between the tires of driven wheels and the road surface propels the vehicle forward. There are four main opposing forces acting on the vehicle: rolling resistance force, aerodynamic drag, uphill resistance, it is also called as grading resistance, and the fourth one is acceleration resistance. Here the word resistance is a common word. In electrical terminology, the resistance is an element which is used to stop the motion of current, stop the motion of electrons. But at the same time, if you use the same resistance word in mechanical terminology, it's a force, it's an opposing force which is used to stop the motion of any object. In electrical, the resistance of the unit of resistance is ohms, whereas in mechanical terminology, the unit of resistance is Newton. So, resistance is a common word, you can use it anywhere accordingly. You have to use a proper units. First, we'll discuss what is rolling resistance, aerodynamic drag, uphill and acceleration resistance with the help of equation. Then we'll move on to Matlab simulation. The first one is nothing but it's a rolling resistance, is nothing but it's a resistance of tires on hard surfaces is due to hysteresis in the tire material. The formula to find out the rolling resistance is m into g into fr into cos alpha. Here m is a mass of vehicle in kilogram, g is acceleration due to gravity, f is rolling resistance coefficient which is normally given by the tire manufacturers. For reference, you can see the table column which is given in this PPT. Car tire on smooth tarmac road, the value is 0.01. Car tire on concrete road, it is 0.011. Car tire on gravel road, it is 0.02. Likewise, it's going on. So this is the value normally given by the manufacturer. And alpha is very important term. It's called road angle, which is in radian. If you take a vehicle, whenever if you're having a vehicle, when the vehicle is traveling in a hill station, this slope is nothing but it's alpha. The slope angle of road in hill stations is called alpha. Suppose if you consider this alpha, definitely the power requirement will be increased, automatically the cost of vehicle will also increase. In case if you omit this alpha, that means if you consider the alpha is equal to 0, then that means that the vehicle is applicable only for planes. Okay, so whenever you are designing any vehicle, whether it is a conventional vehicle or electric vehicle, that doesn't matter. This road angle is very important factor which will help you to climb hill stations or some kind of slopes. Okay, technically this road angle is mentioned in the form of gradability. 100% of gradability means that vehicle can climb even 45 degree of slope. Okay, normally if you take any mid-range of vehicles, they always design the vehicle with 35 to 45 percentage of gradability. That means that vehicle can climb minimum 11 degree to 16 degree of slope. You may came across so many videos. For an example, if you take a Land Rover Discovery or Mitsubishi Pajero, or these vehicles can easily climb 45 degree of slope because they designed the vehicle with the gradability of 100%. Okay, so technically this road angle is normally described in the form of gradability. This is very important concept in vehicle dynamics. The second one is aerodynamic drag. Imagine you are having a two-wheeler and you are riding a two-wheeler in a highway at a speed of 80 km per hour. And definitely the air will oppose you. The air will oppose the motion of vehicle. So that force is nothing but it is an aerodynamic drag. A vehicle traveling at a particular speed encounters a force resisting its motion. This force is nothing but aerodynamic drag. The formula to find out the aerodynamic drag is half into rho into AF into CD into V square. Here rho is the density of air. This value will be normally varied from 1.18 to 1.25 kilogram per meter cube according to the geographical conditions. AF is vehicle frontal area, CD is drag coefficient, V is vehicle speed in meter per second. Here, the AF is nothing but it is a vehicle frontal area. What is vehicle frontal area? If you consider the car is moving in a particular direction, let me take this one. If the car is moving in this direction, let me consider this is the vehicle's frontal area where the first portion of car hits the air. If the frontal area is not given, we can easily calculate the formula is height into width into adjusting value. The adjusting values are given for different kind of vehicles. It's given here. For cars, it is 85%. For bikes, 70%. For trucks, it is 100%. For reference, you can take this tabular column for different CD value and AF value. CD is nothing but it is a drag coefficient. It is a constant where V is vehicle speed in meter per second. The third one is grading resistance. It is also called as uphill resistance. When a vehicle goes up or down a slope, its weight produces a component of force that is always directed downwards. The formula to find out grading resistance is m into g into sine alpha. Here, m is mass of vehicle, g is acceleration due to gravity, and alpha is the road angle in radian. This equation is somewhat very similar to the equation number 1, that is rolling resistance. The fourth equation is acceleration resistance. In addition to the driving resistance occurring in steady state motion, inertial forces also occur during acceleration and braking. Normally, this acceleration resistance may occur in conventional vehicles because the number of moving parts in conventional vehicle is very high when compared to number of moving parts in electric vehicle. So therefore, the acceleration resistance will be always higher in conventional vehicle when compared to electric vehicles. The formula to find out acceleration resistance is lambda into m into dv divided by dt. Here, lambda is rotational inertia constant, m is mass of vehicle, v is nothing but it's a vehicle speed. Therefore, dv divided by dt is nothing but it is an acceleration. So we know that if x is a displacement, then dx divided by dt, that is first derivative of displacement is velocity, d square x divided by dt square, that is second derivative of displacement, or you can say that first derivative of velocity, dv divided by dt is acceleration. So this is very important in simulation. So once the all opposing forces are calculated, then we can easily calculate the total tractive effort required to drive the vehicle. So this is the formula to find out the total tractive effort. That is the addition of rolling resistance plus aerodynamic drag plus grading resistance plus acceleration resistance. Now, if you want to calculate the power required, you can easily multiply the velocity of vehicle with the total tractive effort. The second equation will give you the power required to drive the vehicle. If you want to calculate the torque required on wheels, here, the very important parameter required is radius of wheel. None of the manufacturer won't give you the radius of wheel explicitly. If you take any tire, you can see this kind of markings. The name of the marking is called tire mark sizing. For an example, if you look at here, 225/60R18. Okay, this is a tire mark sizing for free static tires. Free means there is no load applied on the tires. Static means the wheel is stationary. Here the 225 refers, it's a tire width in millimeter. Here unit is very important because each and every parameter is in different units. 225 refers tire width in millimeter. 60 refers aspect ratio in percentage, or means radial construction. The last one, 18, refers, it's a diameter of a rim in inches. It's not a diameter of tire, it's only the diameter of rim in inches. So from this, we have to calculate the radius of wheel. Then only we can calculate the torque required. For an example, if you take this tire, 225/55R17. So this is the given wheel. I'm going to calculate the radius of the wheel. The step 1, we have to write down the parameters and convert all the parameters into millimeter. Width of the tire is 225 millimeter. Aspect ratio is 55%. Diameter in inches is 17. So that will be converted into millimeter, which will give you 431.8 millimeter. The formula to find out height of the fall from the given aspect ratio is height is equal to AR into W divided by 100. This is the formula to find out height. So from this, you can easily calculate height of the tire. The height of the tire here refers this one. This is nothing but it is the height of the tire. There is the upper height and lower height. Remember, diameter of rim is given. Just now we calculated the height of the tire. Therefore, if you want to calculate the diameter of wheel, this is diameter of rim plus 2 into height, which will give you wheel diameter. From this, we can easily calculate the radius of wheel, which is given as 0.339 meter, because this is the value I'm going to use in my simulation. So once the diameter of wheel is calculated, you can easily calculate the torque required on wheels. Next, actually in my first part of simulation, I'm going to simulate the vehicle dynamics with the help of constant velocity. If we want to travel from one place to another place, we never maintain constant velocity. Okay, depends on the road conditions, depends on the application, depends on the acceleration what we are giving. The velocity will be a variable one. You cannot maintain always a constant velocity. But for this simulation, for better understanding, in my first part of simulation, I'm going to use a constant velocity. If the velocity is constant, mathematically I can say that if the velocity is constant, then acceleration is 0. Mathematically, that means if you take dv divided by dt, that is derivative of velocity If the velocity is constant, it will give you 0. But you cannot maintain 0 acceleration. So for better understanding, I am telling you that first I am going to simulate the system with constant velocity and constant acceleration. Later, I'll use a drive cycle source which will give you a variable velocity with respect to time. So before we moving on to that, here itself I'll explain you what is drive cycle source. Drive cycle source is nothing but it's a source plays an important role in simulating road driving behavior while testing the vehicles. Actually, drive cycle source will give you the velocity profile of vehicle under various road conditions. Here, various road conditions means you may drive your vehicle in heavy density of traffic, moderate density of traffic, in hill stations, in highways. This is nothing but it's a different road scenarios. An understanding of drive cycles can benefit the testing of developed vehicle control systems. For electric vehicle, this drive cycle source will provide you the useful information regarding range, battery consumption, and vehicle behavior. Different countries using different drive cycle source. Actually, these drive cycle source and all, it's a real-time values. Okay. US standards are there. So in this PPT, 3 of the US standards are given. The first one is Federal Test Procedure. Second one is Highway Fuel Economy Test. The third one is US 06. Okay, so this will give you the different velocity profile of vehicle under various road conditions. US standards are there, European standards, Chinese standards, Korean standards. Even if you take India, Indian drive cycle source standards are there. But in India, we never use this drive cycle source standards for our modeling. Okay, if you look at this one, the first two are European models, European drive cycle sources. The third one is Indian drive cycle source. Okay, so as of now in India, this drive cycle source is used only for the homologation of 2 and 3 wheelers because the emission and fuel economy results obtained do not match with real-time driving conditions. So whatever the case, we are going to use Federal Test Procedure that belongs to US standards, which is inbuiltly available in Matlab. That's the drive cycle source we are going to use in our simulation. Clear? These are the vehicle specifications I'm going to use in my simulation. The mass of vehicle is 1600 kg, acceleration due to gravity is 9.81, rolling resistance coefficient is 0.01, grading angle is 7 degree. Okay, first I will start with 0 degree and then I will show you 7 degree or 15 degree, whatever the case, how actually the power requirement is increasing if you keep on increasing the grading angle. The density of air I'm using is 1.23 kg per meter cube, vehicle frontal area is 2.3, drag coefficient is 0.3, rotational inertia constant is 1.05, and the radius of tire, whatever I am using, is 0.339 meter. Now it is the time to start the simulation. Going to the Matlab. So here, the step 1, we have to create a M file which contains all your vehicle parameters. Okay, here I already created a M file, the mass of vehicle, acceleration due to gravity, alpha, every values. Okay, every values here I created as a M file. The very important thing is the velocity of vehicle, whatever the value here I used, it's a constant value. And the acceleration is also a constant value, but we never maintain constant velocity and constant acceleration. For better understanding, in my first part of simulation, I'll use constant velocity and constant acceleration. Later, I'll use drive cycle source. Clear? So whatever you are typing after this percentage symbol, that will be treated as a command line. It would consider as a part of program. Okay. So make sure that first of all, the step 1, you have to create a M file which clearly declares all your parameters, vehicle parameters, and run the file. Make sure that all the parameters are available in the workspace. Now I'll move on to the Simulink where I'm going to create the vehicle modeling with respect to this equation. If you want, you can take these equations as a reference. Okay, I'm starting from the rolling distance. For that, I'm creating a subsystem. This subsystem contains one input and one output. I don't want this one. I'll create my own. So I'm getting inside. I'm deleting all the inputs and outputs. Similarly, I'm going to create 4 subsystems because I'm having 4 equations. Yes. So according to the equation, I'm going to create a rolling distance, aerodynamic, grading distance, and acceleration distance. We're getting inside rolling distance. There are 4 constants. It will take a constant block. And the last one is it's a road angle. That's in actually degree. You have to convert this road angle into radian. For conversion degree to radian in Matlab, the inbuilt block is available. I need a trigonometric function cos. Then according to the equation, you can multiply all these values. I need a product. The input of product is only 2 here. You can increase the number of inputs as 4 according to your requirement. The values and all I will let you know later at the end of the simulation. Now, if you want to take this signal as output, you can use out terminal. You can rename it FRR. Now you can see, just come back, you can see that the rolling resistance force is now available for output, is output. Similarly, you can do the remaining three. This is actually 0.5. It is 1 by 2. You can take this second equation as a reference. Half into rho into AF into CD into V square. So in my first simulation, I'm going to use the velocity as a constant. Okay. Okay. Now if you look at this, the velocity of vehicle is in kilometer per hour. As per the equation, I want in meter per second. So you have to convert this kilometer per hour into meter per second first. So let me take a gain, and that conversion value is 1000 divided by 3600, which will convert kilometer per hour into meter per second. And as per the equation, it is V square. So let me take square. Similarly, you can multiply all the terms. Half into rho into AF into CD into V square. You can take this signal out with the help of out terminal. There will be FAD. Unit is Newton. If you check out the grading resistance, this equation will be very similar to first equation. Third equation is similar to first equation, only there is change in, instead of cos alpha you have to use sin alpha. So what I'm doing is getting inside, I'm copying all the things. I don't want rolling resistance coefficient. Similarly, I'm going to reduce the number of inputs as 3. Here you can change the trigonometric function from cos to sine. That's all. And then the last one is acceleration. I need mass of vehicle. rotational inertia coefficient. The second one is and the last one is acceleration of vehicle in meter per second square. Now, all opposing forces are available for measurement. At last, you can add all the forces. Increase the number of input ports in addition term. If you want to see the output, you can use a display, because whatever the input we are using, it's only constant. Therefore, you can use display as output. Suppose if your input is a variable with respect to time, you have to use scope. Let me take its total tractive effort in Newton. Now, if you want to calculate the power according to the equation, the formula is total tractive force multiplied with velocity of vehicle. Go to aerodynamic, take the same velocity without square term. Copy it, place it outside. Just multiply the power with the velocity, which will give you power required in watts. If you want to see about the power in kilowatts, it's very easy to understand the power in kilowatt. So let me take a constant, and the constant value is 1000. If you divide the watts by 1000, it will give you kilowatt. At last, if you want to calculate the torque required, I need a product. I need one more constant, that is nothing but it is the radius of wheel. So multiply this radius of wheel with the total tractive effort, that is force into radius, which will give you torque in Newton meter. Now the simulation is ready. We have to feed the inputs. We already defined the parameters as a M file. So whatever the variable name I'm using here, you have to use the same variable name. Okay. Suppose if you are using, it's very highly case sensitive. If you are using any other variable name, it will definitely throws you error that I will show you. So if you listen here, whatever the mass, for mass, whatever the variable name I'm using, it's capital M. Okay. I'm just going to the Matlab, go to this vehicle dynamics. Let me say if it is M, it won't throws you any error because the capital M is already defined. Suppose if you use small m, the moment you put apply, it will shows that the variable m does not exist. You can see. So it should be it's highly case sensitive. You have to use the same name whatever you are declaring as a variable name. Okay. So let me do it one. This is capital M. Road angle is alpha. This is alpha. Lambda. And this one is ACC. This is also same V. This is R, radius of V. So make sure that you have executed this M file and all the values are available in the workspace. So in the first case, whatever the alpha value I'm using is 0 because just I want to show you if you increase the slope angle, how the power requirement, torque requirement is getting increased. That's why you can say that why Land Rover different is costly, because they designed the engine according to the requirement of 100% gradability. Okay, just see, I'll show you once it is executed. Now you can go for the simulation. Run the file. See, for 0 degree, that is I'm not considering any slope, the power requirement is coming around 9.433 kilowatt, and if you look at this, the total tractive effort is 424.5 Newton. At the same time, the torque requirement is 143.9 Newton meter. Now what I'm showing you is I'll increase the alpha value as 7 degree. Okay, don't forget, run the program, check whether the values are updated in the workspace. Now you go to vehicle dynamics. So whatever the previous value was, 9.433 kilowatt. Now if you run this one, for 7 degree of slope, you can see that the power requirement is increased from 9 kilowatts to 51.91 kilowatts. That's why the vehicles are costly. If you go to upper rates. Okay, so this is nothing but it is a vehicle dynamics modeling. Now, whatever we did, the simulation is completely wrong. Actually, it's not about wrong. The way how I'm giving the input is wrong. We never maintain a constant velocity as well as we never maintain a constant acceleration. See, mathematically, if the velocity is constant, acceleration is zero, right? But it is very hard to maintain a constant velocity as well as constant acceleration. Practically, it is not possible. That's why we are using drive cycle source. Drive cycle source will give you velocity profile of vehicle under various road conditions. Each and every country is having their own drive cycle source. This is very important concept. Now I'm going to use one kind which is available in Matlab. We take drive cycle source. So this is nothing but it's a drive cycle source. It's a Federal Test Procedure 75. It's having an input data of 2474 seconds. Just double click it. If you want the drive cycle source in meter per second or kilometer per hour or miles per hour, whatever the unit you want, you can take it out. Only you have to mention what is the output you want. So here the thing is, you need not to convert kilometer per hour into meter per second. This is not required actually if you use drive cycle source. Suppose if you want to use your own drive cycle source, you can import the drive cycle source as an Excel sheet. That is also possible in Matlab. Now I'll show you what is the drive cycle source here. I'm going to plot the drive cycle source. See, this drive cycle source is having a data of up to 2474 seconds. Time in x-axis and velocity in meter per second is in y-axis. That means that, see, this is the place where driver started the vehicle and he went up to some speed, again applied a brake, again went to speed, again applied a brake. That means that this profile will shows you that the driver drives his vehicle in a high density of traffic. If you look at here, between approximately 1300 seconds to 1900 seconds, there is no output. That means that the vehicle was struck up in a heavy traffic. Even he cannot move his vehicle even a single inch. Okay, even 1 inch. So that's the meaning of this profile actually. So I'm going to use this drive cycle source as an input to study my vehicle behavior. Whatever the unit I want is meter per second. Let me click OK. Now, so you can remove this vehicle velocity as well as this conversion rate. You can straight away connect this drive cycle source here. Similarly, if you go to equation number 2, that is aerodynamic drag, we are having vehicle velocity. So if you want to take this drive cycle source as an input, here you need to create one input port. Okay, delete this velocity as well as the gain part, that is a conversion part. Don't delete square term. As per the equation, it is v square. Okay, connect this input port here. Let me say it is velocity in meter per second. Just come back. You can see that you are having input port. Simply connect this one. Now the velocity is over. What about acceleration? If you come to this equation number 4, that is acceleration distance, you are having the acceleration. Similarly, delete this acceleration, create one input port, rename that input port as acceleration. It's in meter per second square. But the problem is, whatever the data I'm having, it's a velocity. But whatever here required is its acceleration. How to convert velocity into acceleration? It's very simple. Take derivative of velocity. Derivative of velocity will give you acceleration. We take derivative term. Derivative of velocity will give you acceleration. That's all. So this is nothing but the vehicle dynamics modeling with drive cycle source. But the problem is, you cannot use these kind of displays. You have to use a scope because my input is variable with respect to time. Okay, so I'm deleting all this display. Instead you have to use scope. We take a scope. For clear visualization, I'm changing the background of scope. Go to view, go to style. Take this figure color as white, axis color as white, pen color as black. Take this one too. This one is actually, it is a total tractive effort in Newton. This is power required in watt. That's all. So one more thing, it's very important. Whatever the input value I'm having is 2474 seconds. But whatever the stop time here mentioned is 10 seconds. Make sure that this is also a minimum of 2500. Then only it will give you the complete output. Otherwise, it will give you only zero output. Okay. So hereafter, in this vehicle dynamics parameter, we don't want this velocity. So I'm just making this as a comment line. We don't want acceleration. You can delete it or you can make it as a comment. Both are okay. Okay. Run the file and come back to the simulation. Now if you run the system, with respect to the drive cycle source, that is Federal Test Procedure 75, it will give you the total tractive effort, power required, torque required. It's clear that this is the total tractive effort. You can see this, these portions and all, the torque requirement when the driver applied the acceleration. These and all when driver applied the brake actually. At the same time, if you look at this power requirement, the maximum power required for this drive cycle source, it's going up to approximately, I can say that 74 kilowatt. 74 kilowatt is the maximum power required to drive this input. At the same time, you can check it out the torque also. What will be the maximum torque it's going? Okay, so whenever the torque is going in negative, that means that So if you look at this, some places the torque is going in negative. That means that the driver applied the brake. So this is the way you can study the vehicle dynamics with different kind of drive cycle source, which will greatly help you to design your battery pack as well as the machine pack. So remember, always the first step towards the vehicle dynamics, vehicle design is not a battery, not a machine. We have to study about what is vehicle, what is the size of vehicle, whether it is a two-wheeler, three-wheeler, or four-wheeler. Whether it is a it comes if it is a four-wheeler, if it is comes under the category of mid-range or high range, whatever the case. So whether it is a four-seater or seven-seater, what is the mass of vehicle, what is the opposing forces acting on the vehicle, what is the tire dynamics, what is the vehicle dynamics, what is the size of tire we are going to use. The structural dynamics as well as the vehicle dynamics is very important before developing any vehicles. So based on that only, the next step is you can go for machine design. At, at last you can go for battery pack. That battery pack will satisfy all these criteria. So whatever the drive cycle source I am using here, it's only one drive cycle source. In real time, you have to do the same kind of simulation for different drive cycle source. So from that different drive cycle source, you'll get different total tractive effort, power required, torque required. So from that number of powers and torques available, we have to choose the maximum power and maximum torque. Then that machine will satisfy all driving conditions. I hope this video will greatly helpful you to know about what is vehicle dynamics modeling with the help of Matlab and then study of drive cycle source. Thank you very much. Kindly subscribe the channel. If you want to mail me, kindly use this mail ID. Thank you.